A2 Database and SQL exam questions. It's the June 2013 questions specifically. So I've called it Database Terminology, but really it's to do with the questions that appeared in the June 13. They are typical of questions. I like the June 13 paper because it really is typical of the type of questions you get on database and SQL. And it's always going to ask you why something is in normal form or how to get it into normal form, because it's in 2NF, second normal form. And those are the two questions you've got to just simply revise for. 1NF, 2NF, and 3NF. And if you want, there's statements you can learn by rote, but let's look at 3NF and see if you can fully understand it, and then maybe you can understand the other normal forms from this. So it says, what does this mean, i.e. third normal form? And why is it important that the relations in a relational database are in third normal form? Well, what is the meaning and why is it important? And we know that when you normalize a database, you get rid of redundant data and you start making the database more efficient. So this is the answer, but then I'm going to show you an example. The answer is every attribute in relation is dependent on the key, the whole key and nothing but the key. Alright, so if I've got a student table in my database, every single attribute or field, if you like, in that table is dependent on the student ID, okay, which is the key, the primary key. Why is it important? It eliminates data redundancy. So when we have one student making many fee payments, we have another table called fee payments, and that ID of the student appears in the fee payments table because he pays fees on certain dates or whatever the case is, but he pays a fee, and we drag over his primary key and it becomes a foreign key. Every single attribute belonging to a student is therefore immediately in relationship with fee payment. I want to show you this. This is a fully normalized customer order form. This is standard. A lot of databases look like this. And this is from the Access example of the Northwind database. Now, a customer will make many orders, but many orders will have many details. And in the details, or if you like, you could call this the invoice table, are many products. It's fully normalized because that table there, products, has one key, and the name and the unit price of that product are completely and utterly dependent on that. So when we drag over product ID, all of that comes along with it. We do not repeat that data. There is no redundant data. There is no duplicate data, in other words. So this is an example of a fully normalized database. And the June 2013 paper had this kind of a setup in mind. They called it different names and they called it a furniture company, but it was essentially this. Now this question B, on the incomplete entity relationship diagram below, show the degree of any three relationships that exist between the entities. Straight away, this is your product. Let's just go back to that example. Do you see there's the product? One product appears many times as a detail on the order. So one furniture item appears many times on the detail of the order. So one furniture, and this is how I would do it, and I'll jot it down or think about it in my head. One customer can have many orders. So one customer has many orders. Okay, let's go back to that one there. One customer has many orders. There it is there. But one customer order has many details or order lines. Okay, and those order lines could be all sorts of details relating to that. Okay, what about furniture? Well, one furniture appears many times as detail on this customer order line table. So order line is just another way of saying more details on the order. What will be held in this customer order table? Well, it could be as much as this, but essentially it's going to be the date. Alright, and notice that in the June 2013 they had this Access Northwind standard template database in mind, because they said at the end, add in an employee table. Strictly speaking, by the way, you see the S here, that's not quite right. It should be customer, not customers. An entity is singular. We always think of one customer, one order, although ultimately there'll be lots of customers in this table as instances of the attributes. And what is an attribute? That's an attribute, that's an attribute, that's an attribute, that's an attribute, that's an attribute. Another word is field. These are attributes of the entity customer. Notice the singular. It says customers here. That is not right. Access got it wrong. Right. One customer can have many orders. So one to many. One customer order can have many order lines or details, and one furniture can appear many times on the order line. Okay, so one is to many, one is to many, one is to many. That would be fully normalized. Question 9C on the June 13 paper. Complete the following data definition language, DDL. What's a data definition language? Well, it's a fancy way of saying, you know what, if you were to write statements about how to set up a table, and that table name was furniture, what are the field names or attributes, and what are their data types? Computing, and especially A2 computing, is full of acronyms. It's full of these things. But actually, I want you to know that a lot of these things are very simple in that you have done them and know them. Basically, this is like what you've done in Comp4. You've set up a table, you've said what the field name is and what the data type is. And this is exactly what it is, except you're not doing it in a table, although you might get a mark if you want to set up a table, but you're just simply writing statements. You're going to write furniture ID, that's my first field. The reason why we bracket it and we have a little arrow saying primary key is because it is my key field. That's my key field. As int, that's the data type, as integer. If you said as number, not quite right for a programmer, but it's okay. Rather just say integer. Access will just say number, won't it? But we're not talking access, we're talking DDL. Furniture name as variable character. Now that's alphanumeric, isn't it? It's alphanumeric, and it's essentially got a parameter or a limit of 30 characters. So it's alphanumeric, meaning any sorts of characters, because the furniture name might actually have, it might be for IKEA, it might be Swedish, so it will need to be characters, because it might have some strange characters, but there is a limit of 30. And for furniture names, that's pretty generous, that's fine. So our variable character field has a limit of 30. Here, category, that's also text, but safer to just say alphanumeric or varchar or variable character field, and the parameter limit length, sorry, that's what I wanted to say, the string length or the varchar length is 10. We can accept 10 characters, including spaces. Watch out for that, that might come up as a trick question if they talk about needing a space between characters. A space is a character. Price, small money, I like that. I haven't come across that one in reality in working with databases for many years. If you said currency, I would think that's completely acceptable. Currency, small money, that's an interesting one. I'll look more into that if you want me to, but currency is the obvious one, but this is the examiners say small money. Supplier name, varchar 20, supplier name. Okay, that's quite, suppliers could be bigger than that, but you decide what's sensible. And that's a statement about how to set up a table or an entity called furniture. Okay, and it starts with the statement create table furniture, and then you begin furniture ID as integer. That's my primary key. Now it doesn't matter how you jot this down really, as long as you've got sensible names and sensible data types. And this is easy marks. Now, 9D, a fault has been identified with the product that has furniture ID number 10765. The manager needs a list of the names and telephone numbers of all the customers who have purchased this item of furniture so that they can be contacted. it's obviously a chair with a wobbly leg, and everybody's going to fall over when they sit down. So furniture number, item number 10765 needs to be located. This list should contain no additional details and must be presented in alphabetical order of the names of the customers. I beg your pardon, it's not the furniture they want the customers who bought that. Well, straight away, which one are you going to find that on? All the customers who ordered. So you're going to need that table, you're going to need the detail table, and you're going to need the furniture or product table. 3 tables straight away. Alright, so that should be select. I don't know what happened there, but here we go. Write an SQL query statements that will produce the list. Alright, select customer name, telephone number from customer, customer order line, where furniture ID equals 10765. Hold on a minute. Let's just have a look there. So select the customer name, the telephone number from customer and customer order and customer order line. Why? From 3 tables. Going back to our 4 entities, this will have the furniture ID, this will have the full customer details, including their telephone number, and this order table, the main reason why we want it is because it links us to the detail which has got the furniture item on. So we need that link. Yeah, we need the relationship. So from customer, customer order, and customer order line. Actually, beg your pardon, obviously we've only got the ID lent over, so we don't need that table at all. We've already got the ID in there. So from customer, customer order, and customer order line, where furniture ID equals 10765. You say, but furniture ID is here. No, it's a foreign key here, because this is where you list that piece that has been ordered. Okay? And customer.customer ID equals custom order.customer ID. Okay, what does that mean? Whenever you get an and, it's inclusive. Okay? An and is inclusive. In other words, it's the criteria, excuse me, it's the criteria for your selection. These are the parameters, if you like. 1076 underneath the furniture ID will only return all orders that have that item in. But it's also, what do we want to return? We want to return the customer ID. Okay, we will find that same ID in the customer order table, and we will find the customer order and order ID in the customer order table, the customer order line order ID, and then this here is just to simply say order by customer name ascending. Well, that's just to get it looking nice and dandy, really. We don't. Well, did it tell us that? Yes, alphabetical order. Sorry, so it is a criteria. Now this is very easy to show using the North Wind one. Yeah, let's just go back. So we need that. We need their name. Right, this has got first and last, which is typical of a fully normalized database, because we don't want to put 2 attributes or an attribute into one field that could be split into 2. And we need their phone number. We then need the ID of the order, and then we need the product ID. There it is there. So that would be furniture ID in our example. So where furniture ID equals 10765 and the customer ID equals the customer order.customer ID. Okay, so we've got 2 fields, alright, one from customer table, one from customer order table, having to be equivalent, and likewise with our order ID coming from customer order and customer order line. And then we've got to order in ascending order. Okay. Now, yeah, and that's that. That's the SQL. So select, come on, mention the tables you've got to select from, and the fields that you're going to need. You're going to need customer, customer order line as tables, and the fields are customer name and telephone number. Okay, right. June 13, 9E. The system requirements have changed. When an order is placed, the system must now record the name of the salesperson who took the order. The name of the salesperson who took the order. Employee. And place one tick next to the correct SQL command below that should be used to update the structure. It's an update command in SQL to update the structure of the database so that this information can be recorded. Alter table. Hey, pretty good. But remember, in the up-and-coming exams, because we've had alter table, perhaps we're going to be asked to create a new field or insert a column. Now, actually, inserting a column is not the SQL I would use if you need to insert a field. That's not SQL as far as I'm aware. So I doubt that would, yeah, that's not SQL. It's not familiar to me anyway. And create field, append to a field, yeah. So append when you need to add something on through SQL, but create field, no. So alter table, very good. That's the one. Okay, and I think, yeah, I got one more because I'm expecting an insert statement to be asked of you for this exam coming up. So I've popped this in. The insert into statement is used to insert new records in a table. SQL insert into syntax. This is the syntax for the insert into, and there's two forms. This one, insert into, and then the name of the table, these values, and then list the values. That's it. However, I want to show you the other form in case they give you this form. And it's insert and then into underneath. What's the difference? Well, they're both acceptable, really. We can just use that. So this is another syntax. The second form specifies both the column names and the values to be inserted. So that I'm familiar with, and that I reckon you'll be asked to put as an answer to the question. Write an insert statement or insert into statement, and they might give you the scenario, and then you have to put the table name and the values. This here says column 1, column 2, column 3 values, value 1, value 2, value 3. So it's the column name and the values. Column name is a bit ambiguous. We mean field names rarely. Okay, so I wouldn't worry too much about that one. It's that one we're interested in, and I hope that helps with not just the exam question, but that basic information about normalization, SQL statements, and looking at relationships between entities.